Alright, hey guys, in this video we're going to be doing 1C.2, and we should be able to simplify radicals by identifying a perfect square as a factor of a radicand. Some two vocabularies is, well, what is a perfect square? A perfect square is a number made by squaring a whole number. Right, so a perfect square could be any number multiplied by itself, right, 2 times. So example can be 3 squared. Well, 3 times 3 is 9. So 9 is a perfect square. 5 squared. That means 5 times 5. So 25 is a perfect square. Ooh, excuse me. The next vocab word is the product property of square roots. So this one, kind of a long definition, but I'll kind of give you an example of it right below it. So it's for any two numbers the square root of the product is equal to the product of each square root. I do apologize for my board being so kind of sloppy, it's hard to see. So again, what it says is for any two numbers, the square root of the product is equal to the product of each square root. So what does that mean? Well, if they have the same root number, so for example, if I have the square root and I have a times b underneath my radical, what I can do is I can separate them into the square root of a times the square root of b. Right? Just likewise, if they have the same root number, I can combine them later if I need to be under one radical. Or with some numbers, an example like 4 times 25. Right? Each of these are perfect squares. I can separate these to become the square root of 4 times the square root of 25. Right? I can separate them. So that's the product property of square roots. Now, looking at the bottom, I think it's best to kind of have these next couple of examples of perfect squares so that hopefully we get to use to seeing these, we can recognize them faster when solving some examples. So, fill these in with me. 1 squared literally means 1 times 1, right? 1 times 1 is 1. Next one, 2 squared means 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared is 81. 10 squared, 100. Remember that exponent tells you how many times to multiply the base. So 11 squared is 11 times 11. 121, 12 squared, 12 times 12, 144, right? Keep going on and so forth. 13 squared, 169, 14 squared, 196, and 15 squared is 225. So yes, you'll always have your calculator available for you, but it's always best to kind of know at least 1 through 15 perfect squares because it's going to make it a lot easier when we start solving these that you kind of can already picture these and simplify the examples that are to come right now. So looking at our first example, example 1 says the square root of 72. Now I want to simplify these as much as I can to see if I could find some type of perfect square so that I can take the square root of that perfect square and simplify my overall answer. So looking at 72, the first thing is, well, what are some factors of 72? How can I multiply to 72 using one of my perfect squares, right? So 72 can be broken down to 2 times 36. And right there, I should see that 36 is a perfect square. So I'm going to go ahead and use my product property of square roots and separate the square root of 2 times the square root of 36. The square root of 36 simplifies to 6. And the square root of 2, nothing happens to it, I just bring it down. Now, when I have a coefficient, right, that 6 is a nice integer, I have to remember to bring it out to the front, in front of that square root of 2. So my final answer here is going to be 6 times the square root of 2. Alright, I'm going to kind of change my color here so we can see example 2. Now I have the square root of 48. So again, you're trying to find numbers that multiply to 48, but that still are some type of perfect square. So if I look at 48, 48 can be broken down to 16 times 3. And 16 is a perfect square. So 16 is a perfect square times 3. Right, the square root of 16 is 4. Right, 4 times 4 gave us 16. That was that perfect square. And don't forget about my square root of 3. The next one, I look at the square root of 49. Well, that one's already nice because that I already see on my chart right above it. Square root of 49 is the perfect square. So my answer here is just 7. Alright, moving down to my next example, example 4. Looking at this example, I have 7 times the square root of 75. So that coefficient of 7 right there, I'm just going to bring him down. And I'm going to try to break up the 75 into something that has a perfect square. So 25 times 3 multiplies to 75. I see that now I can use just the same property as above, the product property of square roots. Kind of break up that square root of 25 times the square root of 3. Square root of 25 simplifies to 5. Oh, I lost my marker. And I can't forget to bring down the square root of 3. However, I'm not done. Now I have 2 coefficients that are getting multiplied in front. So I have to simplify that 7 times 5. And 7 times 5 is 35. Don't forget my square root of 3. And I'm going to go ahead and bring that down. So again, that 35 came from multiplying the 2 coefficients in front. And we can go ahead and move on to example 5. The same concept. I'm going to leave that coefficient of 12 in front, kind of bring them down. And I want to break down the square root of 8. So square root of 8, I can break that down to be 4 times 2. Right? I see that perfect square of a 4. So I'm going to go ahead and separate my radicals. Square root of 4 is 2, so I'm going to bring that 12 down, times 2, because the square root of 4 is 2. And I can't forget to rewrite the square root of 2. Simplifying those coefficients, right? 12 times 2 is 24. Don't forget my radical down here, right? He just gets brought down. So my final answer is 24 times the square root of 2. Alright, last but not least, I have 4 times the square root of 81. I'm going to bring that coefficient of a 4 down, and 81 is actually already a perfect square. Right, it's on our little chart up there, 9 times 9 equals 81, so 81 is a perfect square. So all I have to do is bring down my 9, and 4 times 9 is 36. Alright, that brings us to the end of this video. Again, just kind of try to memorize those square roots, perfect squares. When in doubt, you can always use your calculator. So you can go ahead and move on to Target 1C.2 activity.